This video is going to look how we can display data in psychology. So on your specification, you've got to know how to construct and interpret frequency tables, bar charts, histograms, and scatter graphs as well. So firstly, here are some results from a study. And as you can tell, it's pretty difficult to really tell much from these results. This is when a frequency table becomes useful. Now, there's been many questions in previous papers asking you to draw frequency tables. So you can see we've got the scores here in that first column. So this is that study we've looked at before with the number of balls going into a bucket. The lowest score being 2, all the way up to the highest score being 17. We then tally off how many times it happened, and we get a frequency score. So for this one, for example, the total score of 9 would have a frequency of 13. And really, frequency tables just tell us the number of times the scores occurs. So let's say we did a psychology test, and if 3 people in the class got a score of 65%, then 65 has a frequency of 3. Histograms are graphs that use vertical columns to show frequencies, or how many times each score occurs. Now you've got the scores on the x-axis at the bottom there. How many times you could either score 1, 2, 3, 4, or 5. And then on the y-axis, we've got the frequency, how many times this actually occurred. And the thing that makes histograms different to bar charts is the columns are touching. And we'll go through why a little bit in our lesson. Now, bar charts, on the other hand, are used to describe data that's in category. So these bars don't touch because the data is what we call discrete. You're only in one group or another. So here we've got tennis, netball, football, badminton. Everyone would be in one of those different sports. You wouldn't be in all of them. Now, it's used when data is in categories. And finally, we've got to know about normal distribution curves. Well, a normal distribution curve describes how the spread of data. So if you plotted everyone's data on a graph, if it was normally distributed, you would get this classic bell-shaped curve here. So that could be for shoe size, height in a year group. Most people would have a score somewhere in the middle, and a few people would have scores at the extreme ends of that scale. Now, the characteristics of a normal distribution are it's bell-shaped, it's symmetrical, so it's got the same on either side, and the mean, median, mode all fall around this central point. They're all very similar, the mean, median, and mode.